I am Bruce Laurie, President of the Ivy Foundation. We support policies and innovations which encourage sustainable development in all sectors of the economy, including Canada's building industry. Many Canadians don't appreciate the impact buildings and infrastructure have on the environment, or the role they can play in fighting climate change and adapting to a warming world. We can actually design, build, and operate our homes, offices, factories, and other structures with climate change in mind. But there are things we need to know. Should we build with steel, concrete, or wood? Which is better for our environment? Which is the low-carbon option? Which helps most in our fight against climate change? Architects, policymakers, and building designers wrestle with these questions every day. Fortunately, there are tools to help them make sound environmental decisions, but they are not perfect, and opinions differ with respect to their strengths and limitations. In this video, you will learn about new research from Canada's renowned International Institute for Sustainable Development. Their research team took a close look at the most important of these tools, life cycle assessment. Their report, which they called Emission Omissions, Carbon Accounting Gaps in the Built Environment, identifies significant and surprising gaps in how we account for carbon in buildings. Watch the video and hear from experts on how to make carbon accounting more robust to improve our efforts to reduce carbon emissions from buildings, infrastructure, and our communities.
Addressing climate change is the challenge of our generation. No matter where we live, we feel its effects. For Canadians, reducing greenhouse gas emissions is a priority, and with over 30% of the GHGs coming from the built environment, the building industry can make a real difference. Now, a study by the International Institute for Sustainable Development has thrown new light on our carbon challenge.
For a number of years, engineers, architects, and academics have been working on a way to measure the environmental impacts of different building materials and designs. It's called life cycle assessment, or LCA for short. Done properly, it can point the way to a low-carbon future. LCAs study each stage of the life of a product or structure and add up all the environmental impacts, including greenhouse gas emissions.
First, LCA looks at resource extraction, like harvesting trees or mining for iron or limestone, as well as manufacturing processes which use energy and may release pollutants into the water and air. Next, LCA measures the environmental impact of transporting materials to a building site and of the construction process. These add to the environmental consequences embodied in a building, even though they're just a small part of the picture. Then there's the operating phase, during which things like heating, cooling, lighting, ventilation will generate up to 90% of the building's GHG emissions. Finally, what happens to the end of a building's life? Do the materials get reused or recycled, or do they go to a landfill and decompose? This can make a big difference on GHG emissions.
Life cycle assessment should give designers the information they need to create buildings that meet their clients' needs while minimizing adverse environmental impacts. But LCAs rely on lots of complex information. They employ different assumptions, and to keep things simple, some even overlook important data. So they can produce very different answers to similar questions. If we're serious about reducing carbon emissions in the built environment, we need to know if our LCAs are up to the task or if they need more work to produce results we can trust and use. That's what we had in mind with our study on the global warming potential of the built environment. We had solid research teams and advisors. Together, we identified ways to make LCA more reliable and help designers reduce embedded carbon in commercial and residential structures. This is a real step forward.
The advisory committee for the ISD study brought together building industry stakeholders, designers, academics, and NGOs, including Environmental Defense. We reviewed the evidence, and it was clear that LCAs are an important tool, but they have their limitations as well. If we're going to use LCAs to compare building materials, more work needs to be done to unpack some of the assumptions that go into them. If we're serious about fighting climate change, we have to get the metrics right.
One thing we found in the study is that LCAs can use poor assumptions and overlook important carbon sources. The most significant problem is that LCAs tend to ignore natural or biogenic carbon released through harvesting, including carbon losses from the soil and from conversion of old-growth forests. They also tend to do a poor job of tracking how much carbon is actually sequestered through the full life cycle of a wood product. In essence, today's LCAs assume for every tree cut down, another is planted and grows to maturity, and that no carbon is lost in the process. In many cases, that's not realistic and doesn't reflect what we know about forest regrowth and management practices in Canada. When we controlled for these discrepancies, we found that a wood building could potentially have greater net embodied emissions than one made of concrete or steel. That's not conventional wisdom. But LCA problems do not relate only to the treatment of wood. We also found weak assumptions about greenhouse gas emissions for steel and concrete products that overlook potential land use changes and differences in product origin, production technologies, and design mix. We need to work on these as well.
Forests are very complex systems. They belie the assumptions. We think that we can harvest and that we will see 100% regeneration. But is it true? Even the best regeneration is hitting maybe a mark of about 90%. We need to understand the footprint that we make in the forest, all the way from the cutting of the tree, what we leave behind, what that means all the way along the various channels as we are producing whatever product we're producing, so that we understand what actually the atmosphere is experiencing when we have something in the built environment. And my concern right now is that we only have a part of the picture. And that's actually what the IISD study suggests, is that we are not there yet. We don't understand what the full carbon cycle is in the built environment. And we need to get that right. We can't afford to be wrong.
For people who want more climate-friendly buildings, there are 3 important takeaways from our work. First, we need to put material efficiency and building longevity at the center of our carbon strategies. No matter what mix of materials you choose, use as little as possible to build durable, energy-efficient structures. Second, current LCAs can help us choose the lowest carbon version of a wood, steel, or concrete product. For apples-to-apples comparisons across product categories, there's still more work to do. Finally, buildings always use a mix of materials, so we shouldn't focus on one at the expense of others. Policymakers and leaders in the building industry have to collaborate on incentives for reducing embedded carbon in wood, steel, concrete, and all other building products.
I think the study has a clear message for the building industry and for policymakers. We have to get the carbon accounting right, get the evidence that we need, and put it to work on reducing Canada's greenhouse gas emissions.
The battle against climate change is 3 decades old. But clear and convincing science is moving public opinion in the right direction. A low-carbon future is going to require difficult decisions, and we know that change is always challenging. That's why it's so important to sustain public trust in our climate change policies. In the building sector, that means keeping science at the center of the environmental conversation and using accurate data to make wise decisions.
The IISD study can put us on a better track for mitigating global warming in the built environment. It's a must-read for everyone in the building industry and everyone who is concerned about global warming. The story's not about steel versus wood versus concrete building products. It's about Canada versus climate change, and really, it's about putting the best science to work on our most pressing problem in the world today.